Assalamualaikum warahmatullahi wabarakatuh. Today our group will be present for Coffee Pulper Machine, presented to Lecturer Encik Muhammad Zaharuddin bin Sariman. This is our team member, me, Muhammad Aikal bin Azman, and Muhammad Adli Hakimi bin Saiful Bahari, Adam Hazmi bin Zakaria, and Muhammad Fazrul bin Nordin. Today we are looking at the evolution of the coffee pulper machine, starting with a definition and importance. Pulping is the process of removing the outer skin and pulp from coffee cherries. The primary goal of this step is to ensure efficiency while preserving the overall quality of the bean. Because of this, it remains a critical step in the global coffee supply chain. We go to stage 2, section 2, the early stage. In the early stage, pulping was a strictly manual process using simple hand tools and manual labor. The process faced significant drawbacks. It was slow, labor, labor intensive, and inconsistent quality. Mm, to solve these issues, we saw the shift to hand-operated machine. This era introduced mechanical hand-cranked tools, which provided the immediate benefit of improved processing speed and standardized result. We go to section 4, the modern era. The modern era. Finally, we have entered the modern era of advanced mechanization. Today's technology utilizes fully automated and motor-driven system. Second, speed. This system allow for high volume output to meet global demand. Thirdly, consistency. They provide uniform quality with far less damage to the beans. And sustainability, importantly, modern machines are designed for reduced water and energy consumption. Okay, we go to a background study of the coffee pulper machine. Now let's look at a major turning point in coffee history. The 1850 revolution. This breakthrough came from a British inventor named John Walker, who patented the drum pulper in 1850. The design was clever and effective. It featured the rotating drum covered in copper bulbed ridge, which acted like a non-slip surface to grip the fruit. Coffee cherries were fed into the machine through a hopper. Inside an adjustable pulping bar worked against the drum to neatly separate the pulp from the bean. In terms of performance, this machine operated at approximately 120 RPM. This speed significantly increased processing efficiency and completely transformed the standard for coffee pulping globally. It was the foundation for the high-speed system we use today.
Next, I will explain the objective of the project. This study aims to evaluate and review the advancement of coffee processing technology with a specific focus on the pulper machine and its role in enhancing the pulping efficiency, coffee bean quality, and the overall effectiveness of the coffee processing chains. Next, I will explain the problem statement related to the coffee pulper technology. First, low operation throughput. The primary issue we'll investigate is the extremely low production rate. Manual processing can only handle about 10 to 15 kg of coffee cherries per hour. Next, this limitation creates a critical bottleneck during the peak harvest season. For your information, coffee cherries have a golden window of only about 10 hours before secular breakdown begins. If the pulping process is delayed, the cherries undergo premature fermentation, which ruins the flavor profile and causes the coffee to lose its grains. Second, mechanical grain damage. The second issue involves mechanical damage to the coffee beans. The pressure inside a manual machine is often inconsistent, causing the beans to crack, chip, or be nipped. Next, this damage actually opens the door for microbial infection, when the beans are highly susceptible to mold and fungus during the drying process. This leads premium buyer to reject the harvest, forcing farmer to sell at much lower commercial price, which significantly slash their profit margin. Third, high physical demand and ergonomic risk. Moving on, there is a very high physical demand on the farmer. Operating a hand crank machine for 6 to 8 hours a day lead to chronic muscle strain and ergonomic risk. Next, this fatigue factor indirectly lower work quality as the farmer gets tired. The manually pressure applied to the machine become unstable. This physically strain also forces elderly farmers to spend extra money hiring labor, which future burdens their cash flow. Fourth, quality degradation. Furthermore, we see a significant drop in quality due to the time factor. The quality of a coffee beans depend heavily on how fast it is processed after picking. Next, when its cherry sit in sack for too long under uncontrolled temperature, the natural acidity and aroma of the beans begin to degrade through oxidation. This means that even if a farmer plants a high quality variety, the final product will drop to a low grade due to processing delay. 5. Final, lack of portability. Finally, the most challenging issue in highly plantation area is the lack of portability of current machine. Most motorized pulpers are heavy and stationary. Next, this forces farmer to carry heavy sack of cherry through steep and slippery terrain just to reach the machine. This manual logistic process is not only exhausting, but also increases the risk of workplace accidents and slow down the entire supply chains. Thank you. Next, I will explain the method to overcome the problem statement related to the coffee pulper. First, solar power automation. To solve the speed issue, we are introducing a solar power automation system using a DC motor connected to a solar kit and battery. This machine can process up to 700 kg of cherries per hour. Next, using solar technology provides energy independence for farmers in remote area. They can operate without relying on the power grid or expensive gasoline, making this is highly sustainable solution. Second, precision adjustment mechanism. To prevent bean damage, we develop a precision adjustment mechanism using a spring-loaded plate system. Next, the system is specifically designed to handle the natural size variation of coffee cherries. The mechanism adjusts the pulping pressure in real time as cherry enter the chamber. This ensures 98% skin removal efficiency without crushing the beans, maintaining the specialty coffee grade required by the market. Third, lightweight module design. We also redesigned the structure into a lightweight module frame using high-strength aluminum alloy. The total weight is kept under 25 kg. Next, this module concept makes field maintenance much easier. If a specific part wear out, the farmer can detach the specific module for repair without having to transport the entire machine, which saves a significant amount of time and effort. Fourth, mobilization system. Our solution for the logistic issue is the mobilization system. The frame is ergonomically designed to be worn as a backpack or mount onto a motorcycle. Next, this innovation shifts the traditional work paradigm. Instead of the coffee coming to the machine goes to the source by pulping directly at the harvest site. We eliminate waste labor on transporting heavy sack and ensure the coffee is processed while it is at its fresh heat. 5. Hybrid drive system. Finally, as a technical safety feature, we have included a hybrid drive system. The machine features a dual transmission that allow the user to switch from electric motor mode to manual pedal power easily. Next, the system acts as a critical redundancy plan. If the electrical component fail or if bad weather prevent solar charging, operation can continue without interruption, ensuring the farmer hard work does not go to waste due to a technical failure.
Concept of technology: power supply system solar based for coffee pulper. This is a new innovation for sustaining power using solar panels, batteries, and an inverter. Has been developed to drive an AC electric motor for coffee pulping. The main reason for this technology is for saving costs from eliminating the need for fuel and reducing long-term maintenance needs. Many coffee machines are located in remote or rural areas that are not served by government electricity, such as in Indonesia. While coffee production is high, the quality often remains low due to the poor post-harvest handling. Standard coffee pulpers rely on combustion engines or government-supplied electricity, which lead to high fuel costs, environmental pollution, and limited use in remote areas. This innovation will bring great benefits to certain countries such as Malaysia, Indonesia, and Brazil with high sunlight availability, making it energy independence. So, for the idea or concept and how it works, we make the solar-based power supply system for the for wet coffee pulper to provide an eco-friendly and cost-effective alternative. The core idea were to replacing fuels and grid power. Conventional machines rely on combustion engines, such as petrol and diesel, which are costly and produce pollution or electric motor that is unavailable in rural area. This concept is great for utilizing resources that easy to access to, especially in Malaysia and Indonesia or any high sunlight intensity areas. Reducing the cost and increase the productivity by switching to solar-based AC electric engines. The goal is lower maintenance costs and increase productivity and income of the farmers. The system integrates thousand a 1103.64 volt electric motor, solar panels, a 12-volt 100A battery, an inverter, and a solar charge controller. The result from this machine were effective. Its performance were highly effective and efficient. The machine achieved a high stripping capacity of 783.176 kg per hour. The best result for stripping coffee pulp were found at machine rotational speed of 467 rpm with a mass input of 3 kg of a coffee. Its efficiency is 66.63%. Compared to those conventional machines which is powered by electric, average at 235 kg per hour, and combustion motors average at 206.57 kg per hour. The conclusion we had is power supply system solar based is really great for remote areas where they are not served by the government electricity grid nets. It also helped with the economy impact by the eliminating the fuel, reducing the capital required by farmer, bring environment benefit since it an eco-friendly machine that replace combustion engine that exhaust gas and air pollution. So this is the table from the result from the articles. We can see here the solar powered machine is really great. At experiment 2, which is the weight of the coffee is 3 kilos and the time for it to pulping is really high. And based on the table 5, the weight 3 kilos, the total of weight stripped wet coffee is 1.99, which giving the efficiency at 66.63%. Next, another design on the machine for the coffee pulper machine. We got a mobile pulper machine, which we take a frame of bike, and then put and mounted a pulper machine. This concept to make farmer more efficient during working, which is mobile pulper machine, where the investors using motorcycle frame and mount a coffee pulper onto it by modifying it. It brings benefits toward the operation since its mobile unit allow for immediate peeling after harvest, which is critical because delays in processing can significantly decrease the quality of coffee beans. Conventional pulpers are often large and stationary, forcing farmers to transport heavy unpeeled cherries from the field to a central location, making it to be less fresh. Since 60% of a coffee cherry's weight is just the skin, the pulp, transporting unpeeled fruit wasted significant time and energy. The idea and the concept and how it works for the mobile pulping machine. The idea is to transform motorcycle into a dual-purpose agriculture vehicle that acts as both a transportation unit and a power source for coffee pulping machine. We designed this prototype mobile pulper mounted directly onto a modified motorcycle frame. The machine uses the motorcycle's own engine to power the peeling cylinder via a shaft extender and a pulley belt transmission system. Conventional pulper or traditional pulper are large and stationary, requiring farmers to transport heavy unpeeled coffee cherries to the pulper or the central location. When peeling the coffee at harvested location, it will prevent quality loss of the coffee beans. It also a multifunctional machine. It will create as a normal transporting vehicle and also a peeling unit in the operation. This is the flowchart of the mounted how the mobile pulper machine works. We start off from the manual throttle adjustments to the motorcycle engines, to the modified engine or crankshaft, to the shaft extender, to the drive pulley, to the peeling cylinder, to the on-site processed coffee, to the driven pulley, and then into the pulper machine, whereas we put the coffee cherries and the not dump hopper. For the result, testing proved that the mobile unit can successfully navigate both paved and dirt roads with a steering range of 45 to 50 degrees. The machine can peel over 205 kg per hour in comparison to the human power or semi-mechanized machine which is only 10 to 15 kg per hour. The system requires 0.72 liters of fuel per hour, which approximately 3.5 milliliters of fuel per kilo of coffee cherries processed. The peeling speed for the peeling cylinder is 204 rpm, meanwhile the engines run at 100, 1289 rpm. The peeling success rate achieved is 98.7% for peeled cherries, which surpassing target of 95%. To maneuver the machine is same as normal motorcycle. Its average speed can reach 65 km on paved road. The coffee peeling machine that combines to the Haller machines. Currently, coffee farmers in Bondowoso Regency, Indonesia face high production costs and poverty despite favorable natural resources. Traditional processing requires separate steps for pulping and hulling, which is time-consuming and costly. This this aims to combine machines to cut farmer costs. It also making the machines more efficient by combining multiple post-harvest steps into a single machine. This machine combining a pulper and huller machine into one simultaneously. By streamlining these procedures, production costs are significantly reduced, which directly aims to improve the economic prosperity of rural coffee farmers. This research and design are from Bondowoso Regency, Indonesia. The concept, the idea, and how it works. This machine concept is to eliminate the need for two machines, by redesigning a coffee peeling machine that combines both pulper and huller functions into a single operation to improve farmer welfare. By creating the regular machines require farmers to have multiple machines, which is expensive. This concept will have both function and will reduce the production cost and labor time. Processing cherries into separate locations is time consuming. This machine allows for a more continuous workflow, specifically designed to improve the welfare of farmers. For the result or the outcome, the result was success. The machine perfectly performs pulping and hulling in a single operations without problems. By merging the two machines, the production cost for farmer was greatly reduced. The working capacity for this machine was 320 kilo per hour, and its power come from 10 HP gasoline motor, which provide high torque to peel both the outer skin and inner simultaneously. The design is ergonomic and mobile. It equipped with a wheels allowing it to be easily moved by individual farmers or shared among the farmer group. And that's all from me.
The next one is feature recommendation. As Adam just explained, this technological innovation, which is the first one, solar power system that utilizing AC, electric engine and clean energy to reduce carbon footprint. Second one is mobile purpose by mounting unit on modified motorcycle frame for easy transport to remote farm. And lastly, integrated design by combining propane and hauling into a single multifunctional machine to save costs. And from the innovation, there is our future recommendation to implementation this to Malaysia. Firstly is pilot project deploying mobile units specifically for smallholder farmer to eliminate transport delay. Secondly is knowledge transfer. Government and educational institutions should provide training on maintenance and renewable energy use. Lastly is local sourcing, like using common automotive and industrial parts to ensure repair are cheap and accessible. In the conclusion, we want to say that innovation is moving from labor-intensive to smart, mobile, and solar power system and integrated design. It's very efficiency by reducing costs and transport delay way over on-site processing and sustainability, getting more eco-friendly and provide competitive traffic industry for Malaysia's smallholder. And I would like to end it with this quote, which is modernizing the bin, empowering the farmer. And that is the end for our presentation. Thank you for listening.